So this is a continuation of the notes. I think we already did this one in class, but I just wanted to make sure to re-go over it just in case, just kind of where we left off. So this was the we do, find the inverse. So the first step was to switch the x and the y. Since there is no y here though, you do have to write the y in. So this is y equals x squared. Now, in class, I told you guys that this part over here is just a restriction for your answer. So your answer should be greater than or equal to 0. So we'll get to that once we're done finding the inverse. Whoops. Let's take that off. All right. All right. So we have, okay. So I'm using a pin, not the smartboard. Um, so the first step was to replace the f of x with a y. Second step is to replace your x with your y. So switch your x's and y's around. So x equals y squared. All right. Next step will be to take the square root of y so we can get rid of that squared. So we'll do that in another color. So I'm going to square root this side, which means I also have to square root this side. All right. So you will get y. So I'm going to move this over on the left-hand side. Y equals, you need a plus or minus because you took a square root. So any even root needs a positive or a negative answer. That's where this part comes into play over here because we know that x's should be greater than or equal to 0. Now that excludes this negative part of our answer. So your actual final answer is just strictly y is greater than, or sorry, equal to the square root of x. All right. So that is your, oh, wait a minute. This is not your inverse function because I do want you guys to write it in the original format, which was function notation. So function notation should be f of negative 1 x. So f inverse of x equals the square root of x, which makes sense because x squared, the opposite, is the square root. Now it's not plus or minus because if you did do the plus or minus part, that would no longer be a function. Okay, so you leave it just like that. So basically this part over here, this x is greater than or equal to 0, just took this negative sign off of the answer. All right, so now for the stuff we did not cover in class. So this was going to be a pair share, but you basically approach it the same way. We don't want the f of x because that'll be really messy while we solve it. So you take that off and just put not what I was writing. So pin, pin. So y equals 8 plus the square root of x plus 5. So the first step was we just replaced the f of x with a y. Now we're going to switch our x's with y's and y's with x's. So 8 plus the square root of, this another x, so it turns into y plus 5. All right, so now the hardest part about this is just going to be knowing when to get rid of which of the operations. So we're going to get rid of this 8 first. It's 8 plus this stuff, and it's a positive 8, so we're going to do a minus 8 to get rid of it. So minus 8 on this side. So this is going to be x minus 8 equals, these two are at 0 equivalent, so we're going to do plus that, which is just going to be the square root of y plus 5. All right, and let's extend. All right, so y is not by itself yet. We have that square root symbol. So what we're going to do to cancel that, we're going to exponentiate this side or square this side. We're going to also square this side, and I'm going to go pick up that phone. All right, so continuing this. So now this squared cancels with this square root. And, whoops. Sorry, Mr. Aguirre is a little bit off today. And that will end up being a y plus 5. All right, now this side over here, you actually have to multiply it all out. So what I'm going to do to give myself a little bit more room here, move this off to the side a little bit. Okay, so this side over here, x minus 8 squared, you cannot distribute the squared to both parts because you have two terms inside of here. So what you actually need to do is multiply it out. So it's x minus 8 times another x minus 8. You can multiply this using the box method. You can use it by foiling. You can multiply it by doing the patterns that we learned in class also. but you do have to multiply it out. So x times x is an x squared. You're going to get a negative 8x with another negative 8x, which is a negative 16x, and a negative 8 times a negative 8, which is a positive 64, equals y plus 5. All right, last step to get this y by itself, you got to subtract 5. You got to put it under the 64 because these two are the like terms on this side. So I'm going to kind of switch it around now. So put the y on this side because that's normally where the y goes. And going to get x squared minus a 16x plus a, what is that, a 59. All right, and that is your inverse function. Do keep in mind though that it started off as a f of x function. So you do need to put f inverse of x equals x squared minus 16x plus 59. So if you guys have problems with any of the steps that I did here, please note the time and then on the recording, and then we'll go through it in class tomorrow. All right, so another part we didn't get into in classes was verifying inverses. So this is going to be part of your work on the workday tomorrow. So basically what this says is that if you guys take the composition, so that's the f of g of x, and then you just get x back out. So basically anything that the f function did, or sorry, anything the g function does, the f function undoes, and then you just end up with x. Same way the other way around too. Anything that the f function does, the g function undoes. So both compositions must result in x. So you got to check it with both of them, not just one of them, but you have to do it both ways. Okay, so this is the way that you verify that two functions are inverses. So if someone tells you, hey, I did this problem, these are the inverses, this is the way you would check it. All right, so it's an I do. A student claims that the functions below are inverses of each other. Verify this claim. So the first thing I'm going to do, I'm going to take f of g of x. So you got to do it twice. So the first time, you can do the g of f of x first, but let's just do the f of x first. So f of g of x. So looking at this, I think this was actually one of the problems we already did in class, so we're just verifying here. So looking at them, it seems reasonable that they are inverses of each other, but we got to double check. So f of g of x. So the first step here, this goes back to the composition of functions. So you're going to write the f function, so it's the 2x minus 4. But instead of putting the x, you're going to put a blank spot. All right, so now we're going to fill in the blank spot with our other function, the g of x. That goes on the inside because this tells you right here, g of x goes on the inside. So on the inside goes 1/2 x plus 2. So if we simplify all of this, and they are inverses, then we should end up with the x just being by itself. So the first step is just to multiply, distribute this 2 to both parts. So half of 2 is a 1, so you just end up with x. 2 times 2 is a 4, so you get a plus 4. Since you distributed, the parentheses do drop, and you get a minus 4 here. Okay, now looking at this, positive 4 and a negative 4, those end up being a 0, so x plus 0 is just x. So there you go. So that checks out. F of g of x ends up just being x. Now you do have to check the other way also. So anytime you guys see the directions say verify that these are inverses of each other, you do have to show me both compositions. So with this one, you're going to take 1/2 of x, but it's a blank spot, plus 2. So it's half blank spot plus 2. So inside of this blank spot, let's go ahead and put the 2x minus 4, because that's what your f of x is inside of the g of x. So you're going to put the 2x minus the 4 inside of there. Now it's a matter of simplifying just like the other side. So half of 2 is a 1. That's just going to be a 1x, which is just an x. Half of negative 4 is a negative 2. Since you distributed, the parentheses do drop off. Now you just got a plus 2. And just like similar to the other one, minus 2 plus 2, a negative 2 plus 2 is a 0, and that will just end up being an x. So there you go. Verify this claim. It is now verified. So verified. Okay, next one. This was supposed to be a we do in class. We didn't get to it. verify that the functions below are inverses, so the same thing that we did last time. Um, Now notice that it's f of x and f inverse of x. So when you write this, you're going to put the f of f inverse of x. All right, so let's see here. You're going to write your f function, so it's going to be a negative 3 blank spot plus a 6. Okay, inside of the blank spot goes your inverse function, which is negative 1/3 x plus 2. That was our other function, went inside of this function. So now you distribute to both parts. Negative times a negative is a positive, so you do get a positive x. Negative 3 times a positive 2 is a negative 6. Plus your 6, the parentheses dropped because we distributed. This is another 0, so you end up with just x. All right, check mark. Check. All right, so next one, f of negative 1. Whoops. Wait, yeah, that's right. No whoops. f of f inverse of f of x. All right. This will be, you write your inverse function, negative 1/3, blank spot, plus 2. The blank spot is this x part right here, turned into a blank spot. Now the f of x function goes on the inside. That's this stuff. That goes on the inside here. So you get a negative 3x plus 6. All right, now it's a matter of distributing again. Negative times a negative is a positive. 1/3 of 3 is just a 1, so you get a 1x. Negative 1/3 times 6. If you guys aren't so great with your fractions, you can always put this over 1, top times top, bottom times bottom. 6 times 1 is a 6. 3 times 1 is a 3. 6 over 3 is a 2. Positive times a negative, so it's going to be a minus 2 plus 2. And those are opposites once again, so you get x once again. Since you ended up with x with one composition and the reverse composition, that means that this is verified. Verified. Alrighty. Hopefully your guys' handwriting looks better than mine. Alright. So this may or may not be your assignment in class. We'll see. I might give you guys a worksheet, so don't work on this yet. I might give you this, I might not. So if you want to, you can try to work on it tonight. Work at your own risk. But yeah. All right, so that's your notes. Like I said before, make sure you guys notate any time. I guess the time right here would be good. That should match up with the video anyways. But notate the time frame of when you got confused, and then we'll go over that more at the very beginning of class. Yeah, okay. And that's all. Bye-bye.